Here is an overview of IPv4 addresses. IP address or an Internet Protocol address is a unique numerical label assigned to each device connected to a computer network that uses the Internet Protocol for communication. Think of it as a digital address. Similar to your home address, a digital address allows devices on the Internet to communicate with each other. It basically identifies the network interface of a specific device. Some people think an IP address identifies the device itself, but actually an IP address only identifies the network interface of that specific device. For example, if you have a server with 6, 7 or 10 network interfaces, in other words network ports for example, each of those interfaces will have a different IP address depending on how you have configured the system. Therefore, an IPv4 or even an IPv6 address, what it's doing is identifying the network interface of a specific device, not the device itself. So that's a key thing that some people get confused with. At the end of the day, the primary purpose of an IP address, whether it's an IPv4 or IPv6, is to identify that interface so that it can communicate within the network and can communicate with the rest of the world. So think of it as a street address for your home, for example. There are two types of IP versions in use today, IPv4 and IPv6. IPv4 has 32 bits and IPv6 has 128 bits. And IPv6 provides a larger address space as it has 128 bits to work with. However, most of you are familiar with IPv4 addresses. IPv4 addresses have two categories, public and private. A public IP address is like a global address, allowing devices to connect directly to the internet and can be reached by anyone online. In contrast, a private IPv4 address is used within a local network such as home or office network and is not directly accessible from the internet. In other words, they are not globally routable. In other words, private IPv4 addresses ranges are reserved for internal networks and are not routable through the public internet. And those addresses, those private IPv4 addresses, are within the range of 10.0.0.0/8 with this range, 17.16.0.0 within this range, and 192.168.0.0/16 within this shown range. An example of a public IPv4 address therefore would be something like 174.0.256.230, which is a public internationally or internet routable IP address used by Rogers Communications in Canada, for example. So 174.0.256.230 is an IPv4 address, but however, it is not a private IP address that falls under these three sections shown on your screen. A familiar private IP address. When I go onto my computer and type ipconfig on a Windows machine on command prompt, I get this information displayed on the screen. I have an IPv4 address of 192.168.1.32. I have a subnet mask of 255.255.255.0 and I have a default gateway of 192.168.1.1. Notice this is a IPv6 address for a default gateway. We are just going to ignore IPv6 as that's not what we are focusing on here today. So this is my IP address for the device that is identifying the network interface of my computer. This is a subnet mask associated with the IP address, and this is the default gateway. Now, you may not notice that there's few details that I haven't discussed previously, such as a subnet mask and default gateway. Now, this IP address 192.168.1.32 is what we call a dotted decimal notation IP address. It has 32 bits in length. How do we know it is 32 bits in length? Because each of these are called an octet. There's 4 octet, 1, 2, 3, 4. and each octet contains 8 bits. So you need to think in binary. So 192 in binary, 168 in binary, 1 in binary, 32 in binary. So if each of these octet, what we call, have an 8 bits, because there's 4 octet, it gives us 32 bits. Therefore, this is how an IPv4 end up getting a 32 bits in its address. So 192.168.1.32 have 32 bits, 8 times 4, which will give you 32 bits in that IP address. A subnet mask, which is the next one right here, 255.255.255.0, is a 32-bit number used in IPv4 networking to divide an IP address into the host portions, enabling network segmentation and efficient IP address allocation. It helps determine which part of the IP address identify the network portion and which identify as the host portion. So remember, I told you earlier that every one of these sections are called octet, and you had to think in binary. So in subnet mask, when you have 255.255.255, the binary values for each of these 3 first octets have been already filled. All ones, because 8 ones are 255 in decimal. So we have 8 ones, and 8 ones. So 888, and that's 255, 255, 255, and the very last octet have no ones at all. Therefore, we are going to have the host identify in right there. Keep in mind 0, 0, 0, 0, 0, and the 0 is not identified 32. It's just basically saying the host. So if it is 0 here, that's what the host section showing on this table. So what's really important here is that what the subnet mask is doing is helping us basically fragment or enabling segmentation of IPv4 space, so it is more manageable by network administrators. For most of you, only thing you need to know is an IP address have 8 bits and it identify your network interface, and a subnet mask basically segment which sector in that network that you are belongs to using this same 8-bit configuration, but typically comes in, for example, 255.255.255.0. Another thing I want to point out in this overview is unfamiliar IPv4 addresses, but you may be familiar with. Have you ever heard something called APIPA addresses are something that you sometimes get that cannot be routable? Maybe you have, maybe you have not. But at the end of the day, an IP address, whether it's a IPv4 address by a server or a computer, needs to obtain an IPv4 address from a DSCP or somebody who's associated with handing out IP addresses to the network. Your home router, for example, have a pool of dynamic IP addresses known as DSCPs, dynamic host configuration protocol. That's what it is using, that hand out IP addresses, IPv4 addresses, every single time somebody try to connect to your home network. Now, what happens if your DSCP IP handing fails? In other words, you have a network, people try to connect a device, but it's not getting the IP address it needs from the router, which has the DSCP server built in for most home users. In that situation, you're going to end up with something called APIPA, also known as the Automatic Private IP Addressing, which is built into many systems such as Microsoft Windows versions, for example, Windows 10, 11, Windows Server, etc. And the software itself, the operating system itself, will get an APIPA and assign to the network interface when the DSCP IP configuration fails. And when that happens, you end up getting an IP address in the range of 192.254.0.0 and 169.254.0.0 and 169.254.255.255 with the subnet mask of 255.255.0.0. However, APIPA addresses are not routable and only used for communication within the local network in a way like a last resort effort to have an IP address. But You may familiar with these type of IP addresses because you may have connected to a hotel network, but you don't get internet because you end up getting a PIPA address because you don't have the DHCP assigned by the IPv4 DHCP server. Finally, one more thing I want to let you guys know, there are different IPv4 classes. Those classes are A, B, C, D, and E. And what you may be mostly familiar with probably is going to be the C class, which has the 192 category and or the address range. This is because when the IPv4 was first introduced, the international community decided to divide the IPv4 into classes, allowing more segmentation and usability. For most of you, the only thing you need to know, the IPv4 classes are based on higher bit order, and that it basically changes the address ranges. So for most people, what you need to know is there are different IPv4 classes, and in most situations, what I have seen is most homes and networks use the class C addresses, which ranges within this range shown right here. This is basically an overview of IPv4. This is not meant to be a comprehensive overview. This is meant to be someone who has no idea what an IPv4 and IP address, get familiar with what an IP address is and how IPv4 works. If you want to learn more about IPv4 addressing and also to learn about IPv6, please check my YouTube videos on CCNA courses and get familiar with those concepts. I hope this is helpful to some of you, and until next time, please make sure to thumbs up this video and subscribe to my channel